So let's talk about Azure Data Explorer and Kusto Query Language. So a lot of analogies with diving deep into the sea here, like diving deep into data. The Kusto sort of a play on the words of Jack Kusto, who was a bit of a diver, bit of an explorer. So exploring the ocean, exploring data. That's where that analogy comes from. So it's I put the two together, Azure Data Explorer and Kusto Query Languages. Kind of probably a bit difficult to talk about one without talking about the other. It's a bit like talking about SQL Server without mentioning T-SQL, or T-SQL without mentioning SQL Server. So I'm going to use that as my base really to draw analogies, and I'm sure most people on this call have got at least some degree of SQL experience, probably a bit more. So I'll draw parallels with there, and you probably see things that might be great if they were in SQL or not so great, or things that are a little bit different, things that'll catch you out. Okay, so I'm Martin, friend of Redgate, MVP. Now, I've got down the bottom there a whole load of, certifications. And the reason I put them on there really is because, learning a bit of KQL, it's going to enhance literally all of them certifications. Most of the certifications nowadays, they've got something to do with monitoring, and that's got something to do with KQL. And, this whole ADX KQL thing kind of leads into a lot of monitoring. It's got lots of ties with log analytics. So, getting at least a passing familiarity with KQL in general is probably a good thing if you're doing any sort of work on the Azure platform. And seeing the possibilities that ADX, Azure Data Explorer in general, might give you. I'm sure you're probably not going to run out and use it tomorrow, but you might want to look at it and say, oh, maybe I could use it for this or that, or something different, or at least explore. There's a lot of different databases out on the market at the moment, and this is just one that's it's another string to your bow. So our agenda really is we'll talk a little bit about the history. What is Data Explorer? We're going to get some clusters up and running. I've actually got some pre-built, so we're not going to be sitting there waiting for them, but we might go through the process of provisioning them. We'll see how to ingest data, how to get data into Azure Data Explorer, and how to query it with Kusto Query Language. Mainly, looking at how the similarities with T-SQL. So we'll do a basic example and maybe something a little bit more to point. We'll look at some tooling, and there's various ways of interfacing with Azure Data Explorer, from tools that are dedicated to doing that to other tools like Azure Data Studio, which can do a whole array of things like connect to SQL and other places as well. And then we'll look at some other capabilities. Obviously, we've only got an hour together. We could sit here for a couple of days going over some of the capabilities in Azure Data Explorer. So we're not going to run through that list step by step, but we'll cover all of this as we go. So where did Azure Data Explorer come from? So when I first heard of Azure Data Explorer, the thing that sprang to mind straight away was a tool like, say, SQL Server Management Studio or Azure Data Studio. I thought it was like another UI basically to interface with an array of databases. It turns out it's actually a database in itself. Shares a lot of similarities with a lot of other databases, but it's probably a lot different to databases you've probably seen in the past, although obviously does share a massive amount of similarity. So it was developed internally, basically from the ground up by Microsoft. I can't remember the project name it started with internally, but it started off maybe about 2011, 2012, and it was built with the intention of mining data, aggregating massive amounts of telemetry data. And from its internal roots, it basically gained a lot of traction internally. And now it's like the de facto standard for monitoring Azure internally. And I'm sure you can imagine the amount of data that's actually generated by people's Azure subscriptions all around the world. So that's its main use case. And now, it's replaced things like Splunk and other tools similar to that internally for aggregating and examining telemetry data. And even today, it's got its, log analytics, the monitoring platform that's within Azure itself is pretty much based on Azure Data Explorer. We use KQL to get data out of that, and that in itself can generate massive amounts of data. So it's a fully managed platform as a service database, purposely built with analytics and telemetry in mind. And where it really shines is aggregating massive amounts of data, like terabytes, petabytes of data. So I haven't got a database that big today. And it'd probably be probably pretty boring if we just did queries for the next hour and looked at how fast or slow Azure Data Explorer was. So I'm going to kind of base this presentation just around general Azure Data Explorer topics, things that surprised me when I first started playing with this, things that wowed me, and just we'll talk. If you've got any questions, put them in the chat. Mark and Mikhail can interrupt me anytime. And it's really built for like rapid iterations to explore data, and basically to optimize for interactive ad hoc queries. So the format of this, I'm going to go through these slides for, say, the next 10 minutes or so, and then we're going to be straight into demos. So building on what we've already said about Azure Data Explorer, it's an append-only database. So when our telemetry data goes in, or in fact any other form of data that goes in, it's read-only basically. We don't alter the data once it's going in, and we can delete it, obviously, but once the data's in there, it's not updatable. So it's an append-only stream of records. High velocity, high variance data. And like I say, its strength is like ingestion and then being able to query across huge amounts of data. So take, structured data. It does present a relational model. So as a very rough analogy, if you imagine like SQL Server and you just a whole bunch of tables in there, and that's all you ever did, just create tables, and then you could write queries against those tables. That's essentially what we do in ADX. There's no such things as like primary keys, or there's no foreign keys, no relationships. The relationships are inferred at runtime by like the smarts inside the engine. So the relational model, so to speak, it'll filter, aggregate, joins, very similar, but a little bit different. So having that background of a different database, whether it's SQL Server or anything else, it's a bit of a double-edged sword, really. On the one hand, it's excellent. We know what where clauses are, we know what sorts, and we can draw analogies there. But there might be things within the within Azure Data Explorer itself that we go to do. Things that might be second nature in SQL Server, and we get different results. And one of the things that caught me, I was like, I did like a join, and I was like, yeah, I'll expect this to bring back however many records, and it brought back something completely different. And I'm like, why was that? And I thought I'd made a mistake at first, and actually the defaults are different. So some of the defaults are slightly different, and some of the terminology, although it uses the same kind of words, they mean slightly different things. But the crux of the matter is that it's optimized for interactive ad hoc queries. So I took this diagram straight out of the docs. We can go to the docs and have a look if we need to. But it's a bit of a flow chart. When might you want to use Azure Data Explorer to analyze data? And so, have you got a lot of frequent read-write data? If it's read-write, maybe it's not a good case for Azure Data Explorer, as it's kind of read-only. So go look at something else. Follow the chart right down to the bottom. If you get to Azure Data Explorer, then all good. If you need to go on another path, maybe choose Cosmos DB or SQL Server itself, then all good. But just as you watch some of the stuff that we're going to do over the next hour or so, just keep in your mind some of the things that you might use this for. I'm leaving telemetry data aside, maybe your own data that you want to put into Azure Data Explorer. Like I say, it does present a relational model. You know, the tables are tabular tables, so to speak, rows and columns. So, you know, we could make a data warehouse in here, for example. Obviously, we can't change data. Might that be a good use case? Because we can ingest so much data, and the database can be essentially petabytes in scale, you know, might that be a good back end for something like Power BI? Maybe we can aggregate some large data quicker than we can do in DAX, for example. I don't know. All these questions kind of come up. I don't have the answers to any of them, but they're, you know, the things that you might want to have in the back of your mind and just think about. So just some of the services and features within Microsoft that are using Azure Data Explorer, things like Skype, Xbox, Azure Monitor, as we've talked about. A lot of the security products, Sentinel, Azure Defender, IoT things, they're all using Azure Data Explorer in the background. We can always interrogate them with KQL. So like I say, even if you're not going to get into this in a big way, knowing a bit about KQL can serve you quite well. And a list of big names over there, Ezra and the likes, who are using Azure Data Explorer. So just some diagrams that I took directly from the Azure Architecture Center about, for example, this is ingesting real-time data. So a bit of a spoiler here, there's really two main ways of getting data into Azure Explorer. One is ingesting it in batch data. Obviously, we can do that through a number of ways. Data Factory probably springs to mind, loading through UIs and things like that. But other ways, streaming data in through event hubs or IoT hubs. And fairly recently, Azure introduced the ability to get data from Stream Analytics, so we can get data directly from event hubs, send data to event hubs, put it straight into Azure Data Explorer, no problem. Or we can go through Stream Analytics and then throw the data into Azure Data Explorer. So just before I move on, we talked about the roots of Azure Data Explorer and starting in about 2011. So it started getting real adoption within Microsoft about 2014, 2015. And then it went into a private preview, probably about 2018 or so. And then it was in public preview in late 2019. And then early 2020, it GA'd. So it's been in GA around about 2 years. So it hasn't got huge adoption at the moment, but it's certainly getting there. And there seems to be a big focus from Microsoft into making this a mainstream product. We can see over on the left-hand side or the right-hand side, as I look at it, a whole heap of analytics we can use. And we see down there real-time dashboards. Now, you might think that implies Power BI, and Power BI certainly is one of the things you can use to dashboard against Azure Data Explorer. But within the web UI interface itself, we can create our own dashboards, and we'll do that very, very shortly. So that's basically the ingesting via streaming. And now you see we can also do this via Data Factory. There's another diagram taken from the Azure Architecture Center. So we can pull data across using connectors with Data Factory, put it straight into Azure Data Explorer. Also use things like this one shows Kafka as well as IoT hubs and event hubs. Similar to SQL Server with its external tables where, you know, you can point to, say, Azure Data Lake or somewhere else. You can also do a similar thing within Azure Data Explorer. So you can have external tables pointing to data lakes. And some of the interfaces we can go to there, we've got an application called Kusto Explorer. We'll have a look at that shortly. And we can also use notebooks within Azure Data Studio. We'll definitely have a look at those too. Obviously, you can REST API. Literally everything in Azure is REST-based, so we can use that. And there's support for a variety of dashboarding tools as well. So not just Power BI, things like Tableau, Quilk, even Sisense, which is another visualization tool, and Data Explorer itself has got dashboarding capabilities, and even within the Kusto language itself, regardless of if we're using a fancy UI to create the dashboards for us, there is syntax to signal that we want a visualization created. So first off, I just thought I'd mention this plugin. There's a lot of plugins available for Azure Data Explorer. And one of the plugins that Microsoft have brought out recently is an output plugin for Telegraf. And the reason I mention it here, because I know probably a lot of people watching this have got SQL backgrounds. So this might be useful to generate additional telemetry for SQL Server. Like with any Azure service, obviously we can only take what's made available to us through the login mechanisms themselves. But with something like SQL, we might want extra telemetry from DMVs or our own custom scripts. And Microsoft kind of observed a lot of people were using like third-party solutions to do that, Prometheus and that type of thing, diagnostic logs. They were shipping them off to event hubs, streaming them out to event hubs, and then sticking them directly into Azure Data Explorer. So they kind of brought those two things together and created a Telegraf plugin. And that can basically do the job of the two things. I'm not going to look at this in any detail. I'm only kind of mention it for like information. So getting started. So Microsoft want to make it pretty easy, and they've brought out what they're terming a start for free cluster. So there's no real catch here. Anyone can go create a start for free cluster. You don't need a Azure account or anything like that. You don't need to put in credit card details at all, nothing whatsoever. All you actually need is a Microsoft account. So, you could go off right now, you open yourself a brand new Outlook.com account, Hotmail account, so long as it's a Microsoft account, that's cool. And then you would authenticate in the browser, and away you go. You can start for free cluster. So we'll be doing that in about 2 minutes time. I just wanted to briefly show, again, this is taken from the docs, but the start for free details. So it's essentially made zero friction onboarding. One person, one cluster. Essentially it's one email address or one MSA, one cluster, pretty much built on exactly the same technology as it would if you created an enterprise cluster, which we'll do as well in the Azure portal. It's slimmed down a little bit. There's obviously some things you can't do. We see here that, all the things from the Kusto Query Language down to Microsoft Power Automate and that. You can do those in either the full Azure Data Explorer cluster that you create within the portal or the start for free cluster. But there's a heap of things below, sort of more advanced things, external tables, partitioning, streaming ingestion, Python and R plugins that you can't do with the start for free cluster. But, it's a pretty powerful cluster, 4 cores, 8 gigs of memory, about 100 gigabytes of storage. And that's basically the core functionality. Lasts for a year, but I think they'll probably extend that out, and you probably got it for quite a bit longer than you want. Additionally to that, there's a plugin for Azure Data Studio, which you can also use to create notebooks and interface with ADX itself. So with that is the end of our slides. So let's get over to our first start for free cluster. Now, This what we're looking at the moment is pretty much what we call the web UI. So it's an interface to query Azure Data Explorer. So we'd write our Kusto Query Language within here. So you probably see I'm connected to two clusters at the minute. One's called Help and one's called My Free Cluster. Now, whenever you go to the link, this link up here, AzureDataExplorer.com, you'll come to something like this. You'll be presented with a script that's already in there. You won't have this one. This one's mine. This one is what is in here when you start off. And you're connected to what we call the Help cluster. So the Help cluster is, it's got a URI, and it's pretty much a cluster that Microsoft created to demo the capabilities of ADX and KQL. So you think of it similarly to AdventureWorks or Northwind or whatever we've known in the past. Within the Help cluster, there's a few databases there from Contoso. Obviously, probably familiar with that. Some log data, some metrics data. But when you look around examples, lots of them tend to use these tables down here, which are called storm events. So there's population data and storm events, basically about storm events in the US. Now I've created down here my own cluster. When I get out of here, I'll delete this cluster and show you how you create it. The reason I'm not created it now is just to basically save time. So you get one cluster and you can create one database within there. And that's how you go about doing it. So if you want to ingest data to get started, you just do the data tab and you can do a lot of things in here, create new tables, you can create an external table, you can ingest data, quite a few things you can do within here. But one of the things I wanted to show first of all is the dashboarding capability within here. So I'm just going to create very simply a new dashboard. So we'll call this hybrid virtual group. That's what we'll call our dashboard. And we're in there. So let's go straight into editing it. And the first thing it's going to ask us to do is create a data source. So let's create our data source. So let's use the URI that we just seen for the Help cluster. So I'll just copy that. So our Help cluster is that, sorry, that's going to be the data source name. So I'll call it hybrid virtual group data source. And we want to throw in our cluster URI. We simply want to connect to that. And then once we're connected, we can pick our database. So I'm going to pick the samples database and I'm going to use the storm events tables. Okay, so we just get basically placeholder query. So just to start with, don't need to worry too much about this query for the moment. We'll look at the syntax in a little more detail as we go ahead. I just want to create just a query at the minute. Basically, all we're doing here is summarizing, similar to group and by, but we'll talk more about this as we get into the session. So I'm just going to run that, and that'll give us a table. No big shakes there, but let's add a visual to that. So we can add a visual. I'm going to say we don't want to see it as a table anymore. Maybe we want to see it as a bar chart. Or maybe you want to see it as a line chart, or you know, whatever we want to see it as. We can maybe go for a pie chart. Let's keep the pie chart, and then there's a whole heap of other things you can fill in down here. I won't do that now. I'm sure you're capable of working through that by yourselves. So I'm changing the legend and all that type of thing. We can just apply the changes. And there you see it, that's our tile. Obviously, we can get more pages if we want to. So I guess pretty rudimentary sort of, well, the visuals themselves are quite neat. the whole interface might be a bit rudimentary and a bit basic, but I'm sure it's got potential to move on a little bit. And who knows, maybe it'll get to the Power BI stage or even integrate with that sort of thing. Now you can add other things to that. Obviously, you can add titles and text and all that, but you can parameterize these queries. I'm not going to do that now. And we can, we can export these. We can even give them away, share them, and that sort of thing. But that's basically the visualizations that are in place at the minute. So I said basically, how did I go create that? So if I go over to my cluster, so I will just delete that cluster. We're not going to use this anymore. So I need to type the name of it, my free cluster. Hopefully this won't take a second to delete. We won't be using this free cluster anymore. Well, basically, when you want to create a free cluster, you don't get too many options. All you get to do is say the name of the cluster, and yeah, it's done there. You just get to put the name of the cluster in. I call mine the default name, my free cluster. Obviously, I could call that whatever I liked. You can create the database name, again, whatever you like. The default's my database, and you don't get a heap of options for the location of the cluster. You can't pick sizing or anything like that. You just got to agree to the terms and conditions, and away you go. So that's a free cluster, and that's a good way of getting started. Another great way of getting started is to go to not use the web UI. You can actually write some good Kusto inside what we call the log analytics demo. So it's https aka.ms/la demo. Okay, so this is free. However, you will actually need an Azure account. So that kind of sort of contradicts myself. So I'm going to log in with my Azure credentials. So you do need an Azure account, but the data, you're actually going to be thrown into a different tenant, and you can run queries, obviously no cost to you. And reason I bring this up, it's probably a good way of getting into now KQL. So you can hit queries. Let's say auditing. Let's just pick one at random. And you can see the KQL comes up here. We'll look at this a lot more. You see something for reasonably unfamiliar straight away. We've got two where clauses in there, which we obviously don't see in SQL Server. But that's probably the second of our three ways of getting to know KQL and Kusto Query Language. Obviously, this is within Azure Log Analytics rather than Kusto Explorer. There are actually ways of adding your Log Analytics workspace directly into the Azure Data Explorer. So that's a great way for you to go and experiment with Kusto Query Language. The next thing I really want to move on to is creating an Azure Data Explorer cluster within the portal itself, because there's a few more options for us to go through. So if I go, so again, we're not actually going to create one. I've actually created one already. I'll just point out some of the things, some of the choices we might have to make. Obviously the trivial ones, the resource groups and all that type of thing. Doesn't really matter for this. Right, so one of the first decisions we've got is we can create a dev test deployment, and you can see there straight away they've called it, there's no SLA for the dev test. So don't go creating that in production. But we can also create like storage optimized or compute optimized. Now, depending on which region you go to, you might also see, now I'll just try and choose somewhere in the US to see if I get any other options. And I don't, so you can see there that I've even got less options. Some regions you can create isolated clusters. So, you're isolated on your own hardware. Essentially in the background, these are virtual machines. So let's just pick the compute optimized one. And we'll pick the size. Let's go for the biggest one, 16 cores. And what are our options there? So they're basically virtual machines. And there you go, 16 CPUs, 112 gigs of memory. And so, yeah, you've got a few options there. So you can scale up like that. You can also scale out though. You can go from like, two nodes is probably the minimum you're going to start with. You actually can't go down any less than that. You can't go down below 2, so you can't even go 1. So let's keep that at 2. But you can scale up to pretty much whatever you want. And the scaling up, you can do that manually, or you can have that happen automatically in the background. So when Azure decides that you need to scale up, you can scale up. One thing I will say, when I've done this manually, it's actually taken a little bit of time. So just be aware of that. There's some configurations. If we want to stream data, we actually have to turn it on. It's not on by default. We can enable purging of data. That's basically, if you think of it like a trigger to delete data, it's aimed at like GDPR really. If you get data that goes in there that you absolutely don't want it, it's not meant to be used excessively. So that's that. And we can auto stop the cluster. So there's been no interactions with the cluster in the last period of time. We can stop it, but we can stop it automatically ourselves. So like with any of the Azure services, we've got a whole heap of security stuff that can go in there. And we can also obviously put this within its own network as well. And with the diagnostics, there's actually a whole range of diagnostics that we can get within there. Obviously, you'll need a workspace created as well. We'll have a look at this in the cluster I've got created. But that's basically all the decisions you've got to make. Obviously, the availability zones are going to depend on where you've chosen. But let's go and have a look at the cluster that I've just created. I'll just get out of there. So let's go into this cluster that I've already created. And we can see we actually get two URIs. One URI is going to be how we connect to it in the web URI that we previously seen. And there's another URI there for ingesting data, which is very similar, but it's different. And that's going to be used for basically ingesting data. We can obviously scale up as similar options to what we've seen there with the clusters creation, or we can scale out. Here we've got the option to custom auto scale. And, we can write our own kind of logic to auto scale should we want to. But yeah, optimize it. The auto scale works pretty well, or we can just switch to the manual scale. Now the configurations, few additional options here to what was in the configurations page at setup time. We can actually integrate Python and R into here. We've got to turn these on if we want to turn them on, and turning them on just takes a little bit of time. Your cluster's still usable, but they don't appear straight away. And so there might be some use cases where you really want to integrate Python to do things like machine learning, or to get better visuals. And the way you integrate Python or R is similar to how you might integrate say Python or R scripts within SQL Server. So you're basically similar to writing a stored procedure with the Python or R code inline in quotes. So very similar there. It's kind of a real advanced topic, that, but note that it is there and you can use it if you want to use it. So that's basically a cluster setup. Let's go over now to a tool that we've not seen before, and this tool is Kusto Explorer. So Kusto Explorer is kind of a new tool directly for integrating with Azure Data Studio. So I put a few examples of some Kusto in here. We've connected over here to our help cluster again. So as we've seen before, it's got a samples table. It's just actually connecting. That was disconnected while I was talking. So we just make sure we're on the samples, and we can run some Kusto in here. So yeah, obviously that's a trivial table. It's only got states of the US. But the summarize command, it's similar to a group by in SQL Server. So we're summarizing by state there, and we're obviously doing a count. We can do that with other things as well. So the general construct of Kusto is that you have a data set. So just running, say, the storm events will give us data from the storm events table. And then we pipe that data set to the next command. And the next command here is basically a where clause. And so we're saying where the state is Florida. So we run those. And obviously we're going to get back where the state's Florida. Now we could, this probably isn't going to make sense in this, well, logical sense here. But then, we can have, a different where clause there. So we could say, let's pick a different column where that equals 0. And, you could carry on piping these all day. So we've got, now we're sorting data, and you just carry on like that. You're basically piping one thing into another, We've got this interesting command here called bin. It puts the data into nice little compartments. So basically here, what we're doing, we're summarizing, we're doing a count, and we're binning. We're going to create bins based on the start time of every one day. So put the count of events that have happened into bins of every one day. So slow down. So probably not going to run through all of these here. So you're saying when we run just a table, we get back basically everything. So we're not writing a select star query. If we want to trim down rows, we use the project keyword. So we basically pass the entire data set through, pipe it into the project keyword, and then we can have a list of keywords, well, a list of columns there that we want to get back. Okay, so an interesting one now is, what do you do if you want to translate your SQL into Kusto? So we've actually got some help we can get here. So let's get a new tab open there, and so I can actually run SQL against Azure Data Explorer. So that's basically just select all from storm events. I am not on my correct database there. So let's select the samples database and let's run that. So as expected, that's going to bring us back everything from the storm events table. Like I say, this is meant for aggregating data, really fast to aggregate data, not so fast with select statements. But say we wanted to translate that statement into Kusto, so we can use the explain operator. So I just explain that there and run that. Straight away we get back to Kusto, which would run there. Now this isn't going to work with very gnarly SQL, but it's going to work with a fair amount of, fairly straightforward SQL. So we see there we've got something with a where clause in, and now we've got a top clause. So we can, and that's got a group by in it. So you see there it's translated that into our summarize. So I won't go through any more of the Kusto. What I will do, I'll move on to show another way of interacting with Azure Data Explorer. Well, actually two ways, both within Azure Data Studio that we're probably going to be familiar with. So the first one is basically just, there's an add-in, a Azure Data Explorer add-in that we just have to install. And then we can go ahead and run, create a notebook, select our Kusto kernel, select a different sort of connection, and then write Kusto within a notebook. So here what I'm doing, I'm not actually querying a table. Let's just run this. This probably asked us to connect. Okay, so it's asking us to connect, and I've got a connection there. So you can see down here, the connection type is actually Kusto, Azure Data Explorer. I actually got another add-in that will connect to Azure Monitor logs, where we can, again, write Kusto in there. Obviously, we can do SQL Server. So I'm just going to use that connection in there. And this one here, this is basically a window function. Sort of thing you might do in SQL to get the previous or next row. So I'm not actually querying against a database here. I do have to be connected to a database, but this is basically creating my own table. So I've created a data table there with obviously an integer column, a name, a date of birth, and a string, and I populated it with some data. And what I'm going to do there, I'm just going to, I'm going to use this function here to just get me the next name. So when we use some commands, we've got to serialize them to signal to the compiler that we want something to happen behind the scenes that makes, in this case, our window function possible. So I'm extending. So extend is how we add a column. So we add a column here called next name, and then we're going to project out some columns, and we can see there that we're projecting the next name there. And now we've got our results there. We can see Bill Gates. The next one down is Steve Jobs. The next one down is Grace Hopper, and so on. So that's basically working within the Azure Data Explorer add-in. So just mention one more, and that's a KQL. It's called KQL Magic. It actually came out before the add-in for Data Studio. Might have been superseded a little bit, but it's still fairly useful. So you're going to need a Python kernel, and you can just you can basically install it there. It doesn't take long to install at all. It should be done in a second. Yeah, I'll just clear those. And then if we reload. So what I want to show here is just, we actually need to authenticate to the cluster that we're going to. So what we get is, it pops up a code. So we say we want to connect to this particular tenant. I'm just connecting to the help cluster that we've been connecting to throughout this demo. So it connects to the cluster, and it gives us a code And so what we need to do there is copy that code to the clipboard, and it throws us into a browser session. We can, it should have got a pop-up there asking me to enter the code. Then I'm going to have to authenticate to Azure. And once I've authenticated to Azure, it's like, okay, that's cool. You've authenticated now. Just hop back to Azure Data Explorer, and you can carry on doing whatever you want. And there's a magic command there, similar to how you might run, say, Python or swap to a different language. And we can run any query we like within there. And note that Kusto's got a render command. So you just attach it to the end of any query. Obviously, the query will have to bring back results that make sense for the visualization. And in this case, it's a pie chart. But you can just render the command. In this case, we're rendering it as a pie chart. And you'll get a nice little pie chart. And there's another one there just rendered as a time chart. So lots of charting capabilities within Kusto here. So I will round that off. Just before I go, I just want to mention one thing. So joining data within Kusto. So this is the storm events table. So the storm events database. So there's two tables in there. There's the storm events and population data, both fairly trivial tables. They both got a column called state. So we can, on that, I'll just make sure I'm actually in the database. In there. So you notice I haven't actually specified the column here. It's basically intelligent enough to know there's a state column in both databases, in both tables, and it's joined on there. Now, that has just give us the default join in Kusto, which is actually not an inner join. I'll talk about that in a minute. So say we actually wanted to define that the state column is what we join on. We use syntax like the left table and the right table and the column name, and we join like that. Okay, so like I say, an inner join is not the default. The default is in fact something called a unique inner join, which is something that I'd never heard of. Basically like an inner join, but it just gives you unique values. If we want to specify the type of join that we actually want, all we do is put in the kind and then whatever we want. So that is doing a proper inner join there. So that's bringing back an inner join. So within the join, we actually pipe to the join. You'll notice they're all pipe operators. So here I'm just taking the top 50 records from the storm events table. I'm then piping that to the join operator, and I'm saying I want an inner join. So that's just a little trick for new players. And obviously you got the same type of joins as you would expect within SQL Server there. Similarly, a union. Now a union is another one that sort of might look a bit odd if you're coming from SQL Server. We have something we can put in here with, which is the source. So let me just run this command here. So we've added a column that says, you know, what the source table is. So this row obviously comes from the first branch of the union statement, and we can scroll down here. Sorry, comes from the second branch of the union statement, and this argument 0 obviously comes from the first branch of the union statement there. And that's something that we have to specify within our clause there. Now, a union here, it's not exactly the same as a union in SQL Server. For example, in SQL Server, say we had 4 columns in our first branch and 5 columns in our second branch. Well, that clearly just wouldn't work. So what you would get in Kusto, in Azure Data Explorer, is kind of the sum of those. So you've got 4 columns in the first branch, 5 columns in the second branch, or maybe 1 additional column in the second branch. You would get 5 columns back with absolutely nothing in the 5th column from the first branch, and then the 5th column populated for the second branch. So yeah, you don't get errors like that. So yeah, that's kind of brings us to the I think we're about time.
Okay, what size of telemetry data do you need to then decide that you need to start using ADX? Is this something that you would use for logging of any size of data, or just for large volumes?
I'd say you can use it for, well, you can use it for any size of data, really. Its strength is aggregating extremely large volumes, but it's still going to aggregate smaller volumes fine. So yeah, smaller volumes are probably fine. I guess the trade-off there is, you know, what's the cost of the Data Explorer against maybe something else? Does that answer the question?
Yeah, I think so. Yeah. Cheers.
Could you explain why I would create an Azure Data Explorer cluster resource over creating a Synapse Data Explorer pool? What reasons would I use one over the other?
Right, okay. Maybe not, but I'll have a go. So, so actually something I didn't mention is that now in Synapse, Azure Data Explorer is now part of Synapse. So similar to, you know, a SQL pool, you've now got Data Explorer pools as well. I haven't explored those too much. So why might you use one over the other? Well, I guess the ingestion capabilities of Azure Data Explorer might outweigh, say, the ingestion capabilities of, say, Synapse or something like that. Now, the actual querying, so we haven't gone into depths on the some of the syntax and the keywords that you can use against Azure Data Explorer, but some of that is far more advanced than you might be able to use with SQL. Obviously, a lot of the stuff I've showed today you can do in SQL, you can do in Azure Data Explorer, but you've got some advanced machine learning that just comes out of the box with Azure Data Explorer and the Kusto Query Language. You can obviously integrate Python and R into there. Obviously, you can do that with SQL too. But some of the machine learning capabilities, the time series, so you've got advanced time series analysis in here. You've got some advanced geospatial capabilities. So similar to the geospatial capabilities within SQL Server, you can do similar things, almost identical things in Azure Data Explorer. But the visualizations you can create are like way more advanced. Yeah, so hopefully that gives some food for thought for that. Haven't got a scientific answer for it or anything, but I guess it's just a typical consultant, it depends answer. But yeah, definitely explore some of the more advanced syntax of Kusto, and that might go a long way to answering that question.
Cool, thanks.
Great stuff. So got a question that's coming from Steve, which I think is quite a good one. Is there a sensible way of exporting results from KQL to something we can combine with conventional SQL tables? Can it even be scheduled?
Yeah, you can. Yes, you can support. Yeah, you can definitely get the results of the query. As kind of a trivial way of doing it, you could just come up here and you could export to CSV. Yeah, you can download those there. Can you schedule it? Yeah, I guess like anything within Azure, you've got a variety of ways of scheduling it, from you know, Azure Functions or PowerShell, REST APIs. Not something that I've done. Yeah, but it's obviously perfectly possible. You can also write external tables. So yeah, obviously you could write an external table from SQL Server to Azure Data Explorer, or the other way around. So I've not done that. I've not scheduled any sort of CSV file exports or anything, but yeah, it's perfectly possible.
So slightly related, but still not, is there a way to create something like views to a Kusto data source? Let's say if you have lots of pre-rolled queries that you want to reuse and maybe even want to share, or do we have to share the notebooks and query everything through this notebook interface?
Okay, so I'm not sure about views, but you can definitely write functions. So I actually think there might be some functions in here. Yeah, there's a function there, some functions there. So you can write functions that will obviously put a query together that you can reuse. Views, I've not wrote a view. But sharing a notebook is a good way of, sharing things with your colleagues. Obviously, be careful about the data that's going to go into the notebook. Yeah, we got some materialized views there. I've never actually wrote one. So that obviously acts a little bit like a table itself. So the answer to that question is yes. But I don't know. I've not done it myself. And there's some external tables there. If you root around in the docs, you'll definitely find a way of answering that question. And that external table there is actually, well, it's obviously in the help cluster, but it's looking at some taxi data, some New York taxi data. So the answer to that question is yes. And you can also write functions.
Cool. I guess that was the last of the questions. So a big thanks to everybody for joining, and a big thanks also to Martin for speaking.
Okay, thanks for having me and giving me the opportunity to get up at 3:15 in the morning.
It was a pleasure.
All right.